The temperature inside a room housing computer servers is important to proper function. A Google search for server room temperature yields the following, among other results. According to OpenExtra, server room temperature should not dip below 50 degrees, and it should not exceed 82 degrees Fahrenheit. The optimal range is between 68 and 71 degrees Fahrenheit. For number 11, they are asking us to write an inequality to express the statement, their server room temperature should not dip below 50 degrees Fahrenheit, mathematically, using the letter F to represent the temperature. So this is our temperature. It cannot be below 50 degrees. It can be 50 degrees, and it can be greater than 50 degrees. So we should be looking for greater than or equal to 50 degrees. Number 12. In Lesson 2.4, we learned that Fahrenheit and Celsius temperatures were related by the equation F equals 9/5 C plus 32. Use this to turn your inequality from question 11, and I went ahead and wrote it down here, into an inequality with the variable C. So we're saying that F is equal to this 9/5 C plus 32. So it appears that I could substitute this 9/5 C plus 32 in for F right there. So let's do that right now. Okay, there's our F, and then greater than or equal to 52. All right, on 13, they ask us to solve this inequality and describe what the solution tells us. So I will go ahead and pause. You do the same and work out this inequality. Okay, hopefully you got C is greater than or equal to 10. So what I did is I first subtracted the 32 from both sides. And I got 9/5 C is greater than or equal to 18. And then I needed to divide both sides by 9/5. To divide by a fraction, you multiply by the reciprocal. So I multiply both sides by 5/9. And so here, those two cancel out, the 5's cancel, the 9's cancel. And so 8 times 5/9 gives us 10. So C is greater than or equal to 10. Well, what does that solution tell us? It tells us that the server room temperature should be, well, at least 10 degrees Celsius. Okay? All right, number 14 says, write an inequality to express the statement and should not exceed 82 degrees Fahrenheit. Well, it sounds like to me that it can be 82, but it can't be more than that. In fact, it has to be less than that. So this is kind of what we did in number 11, right? And then 15 says, use the Celsius conversion formula to turn your inequality into one solving variable C. So involving variable C. So I'm going to go ahead and pause and let you do that. Okay, so I hope that you wrote down 9/5 C plus 32 is less than or equal to 82. And then solve this inequality and describe what the solution tells us. We'll solve it just like we did the other one. So I'll pause this, you pause it too, and you solve this inequality. Okay, so again, we subtracted 32 from both sides. And that left us with 9/5 C is less than or equal to 50. So how do we divide by 9/5? We multiply by the reciprocal. So 5/9, 5/9. And rounding to the nearest tenth, we get C is less than or equal to 27 8/10. So what does that tell us? It tells us the server room should be no more than 27.8 degrees Celsius, or you could say at most 27 8/10 degrees Celsius. So I'll pause this and write it down. Okay, and then number 17 says putting your answers to question 13 and 16 together, write a single compound inequality to describe the allowable server room temperatures. Now, remember, it has to be between two different degrees here. So we said, once we got through solving them, that our temperature has to be between 10 degrees Celsius and 27.8 degrees Celsius. And then on 18, it says write a single compound inequality to describe the optimal server room temperature in degrees Fahrenheit. So remember, number 11 said that it had to be at least 50 degrees, but it could not be any more than 82 degrees. Okay, number 19 says use the conversion formula to rewrite your compound inequality from question 18 with variable C. All right, well, let's do that first. We are going to substitute this entire expression in for F right here. So let's do that right now. Okay, all of a sudden we no longer just have two sides of inequality, we have three sides. Well, ask us to solve the inequality to determine the optimal server room temperature in degrees Celsius. Okay, well, how we do this is we do still need to get the C by itself. So I still need to subtract that 32, but I have to subtract it from every side of my inequality. So I get 18 is less than or equal to 9/5 C is less than or equal to 50. And I still have to get the C by itself, so I have to multiply every side by that 5/9. And then that yields 10 is less than or equal to C is less than or equal to 27.8. Then they asked, is that the same thing that we saw in number 17? Why, yes, it is. That makes us awesome.